Okay class, today I want to talk about EMC, electromagnetic compatibility. Okay, do you know what is EMC? Okay, EMC is something like the concept of enabling devices to operate without mutual interference. Okay, we have source here. The type of source is like receivers, natural phenomena, and so on. Okay, it travels to the victims, which is a video system and computers. Okay, what is EMI? EMI is like the electronic devices what travels from source to victim is EMI, electromagnetic interference. EMI is electromagnetic or electrostatic disturbance that causes malfunctioning of electronic devices. Okay, there is coupling here. Coupling is something like transfer of energy from one medium to another medium. Okay, there are 4 types of coupling, which are radiative.
Actually, just stop a bit, yeah. Just
from source to victims is EMI, electromagnetic interference. EMI is something like electromagnetic or electrostatic disturbance that causes malfunctioning of devices. Okay, EMI travels through the process called coupling. Coupling is like the transfer of energy from one medium to another medium. Okay, there are 4 types of coupling, which are first is radiative coupling, conductive coupling, inductive coupling, and capacitive coupling. Okay, so do you understand? So I want to give you all an assignment. Okay, you need to find what the concept you guys understand. Okay, I want to give you an assignment. You need to find each concept of this coupling, and then you need to find how to overcome this coupling. Okay, radiative, Amesh, you do this part. Conductive, Isowe.
okay.
Inductive, Faiz, and then capacitive, Wani. Okay?
Okay.
We'll see next week.
Okay. Okay, start.
Okay, I see you next week. Okay, thank you, class. One, two, three.
Okay, done. She should say.
Okay. 1, 2, 3. Okay.
Hey Didi, this is now the Dr. Ellie one. The question, assignment. Super hard.
Meaning the coupling?
Yes What is conductive? Wow.
I've done my part.
You done your part already?
Yeah?
Hey, show me. Stop.
Show what? I can explain to you on the spot.
Hey, then tell me.
Okay, so what I'm in charge is the inductive coupling. So an inductive coupling is basically Amesh, can't. I'm afraid.
It's okay.
It's okay. I
remember the part.
I will cut. I will cut from here.
Okay.
Inductive coupling. Well, how can this occur? this occurs when two conductors
Yes.
of inductive coupling. Well, it happens when there's two conductors. So when there's a current change flow in one wire, the another wire will have induced voltage. The induced voltage is what causes noise, and what it effectively does is reduce the efficiency of a system or the electronic devices. So you get me?
I think I partly, just some of them I
Okay,
get it.
so basically, like two conductors, some of the applications are transformers
Oh.
and metal detectors. So since this is a big problem,
How to prevent it?
how do we overcome it?
Yeah.
Like
So how to overcome it?
So the first method is to limit the cables running in parallel. And for the second solution is, for whatever reasons, using twisted cables can overcome this problem. And last but not least, or this is the one that I found and have been researched, is
It's okay. It's okay. Just start
final
from
method that I found is to increase the distance between the disturbing cable and the victim cable. So because as I told you just now, one cable, when the current change of the current flow, the another one will be induced voltage. So when we increase the distance between those two, this phenomenon will not occur. So I think it's safe that we use this solution. Of course, there's pros and cons. Like using twisted cables are more expensive. But think about it. If there's reduced inefficiency, wouldn't it be better if we invest more and gain more profit later? So I've done my part, which is the inductive. What about yours? Have you done anything?
Oh, because just now I was playing games, so I think I will try to search from now on. Let me search. Let me try and see. Oh, okay. Oh, my one is conductive.
Oh.
Conductive coupling. Here say that there is two type of conductive coupling. One is common mode, and then one is differential mode. And then the differential mode is occur when the noise is out of the phase between the two circuits. And then here's saying that the fitting technique required will vary according to the type of coupling experience.
Ayo, why you use phone all the time? You didn't research beforehand.
Just now I was just sleeping. You see, very hard, you know. So I need to try to find myself. But luckily I got search and I think I got wrote it in the words. So I think no problem. Assignment still can die.
Oh, sure.
Yeah, the conductor, you know conductor. Here says that it's very interesting, you know. It says that conducted coupling is the emission occurs, as the name implies, where there is a conduction route along which the signals can travel. Means that there is a two power cables and there is a two circuit. One is power cables and then one is a communication. So where there is an impedance, so they will be occurring the coupling. The coupling will be occurs. So that will affect the signals transferring.
So how to overcome the problem, may I ask?
Oh, okay. Here, wait there. Oh, this. If you want to overcome it, you have to reduce the impedance. Okay. After you reduce impedance, you have to mesh the common reference. There is a two circuit, so you have to mesh it, and then you have to find the impedance and then you reduce it, and then use the short cables or flat braids, which for equal size have a lower impedance than around cables, which is use the flat.
I see.
Yeah. So and then here says that install a functional equal potential bonding between devices, also a way to reduce the conductive coupling. Yeah, and then the last one, reduce the level of disturbance current. So when you reduce the current, then the impedance will be less, and then you will have the less occurring the conductive will be less occur.
Oh, I see. That makes sense. So, but dude, remember next time, be prepared all the time. So when she asks you in the class, you don't need to refer phone or
Yeah.
books. Okay?
Okay, sure. That's why we go to library.
Okay, let's go.
Let's go.
This is so hard, Amesh.
It's okay. That's why we are in the library. Wait, I have an idea. See?
So Amesh, look what I found. Okay, so the capacitive coupling is occurs between the power and the telecommunication lines, and the capacitive is caused by the coupling that happen between the two lines. So the value of the capacitor itself, it varies according to the distance between the lines. Or should I say, if it shorter distance, it has higher capacitance. But if if it has longer distance, it will have lower capacitance. That's what I understand about this.
Oh, actually, that's actually very similar to mine as well. Do you know what are the how to overcome these problems?
How to overcome this problem? Let's see. Let me see. So, well, I think to overcome this problem, to reduce the voltage noise level, we should decrease the capacitance, or we should increase the impedance in the circuit itself.
I think yeah, that's actually quite related to mine because I'm actually doing radiative coupling. So if you see what I found, you can see that actually radiating coupling is actually quite different to the other types of coupling, because actually it's the only possible coupling mechanism where the source and the victim are separated by many wavelengths or quite a big distance. So when radiating coupling is when the source emits the EMI and it reaches a circuit and induces a voltage or current in that circuit. So unlike the impedance coupling or even the magnetic coupling, it doesn't actually have interaction other than the medium of air that's used in radiating coupling. So actually the level of disturbance in radiating coupling actually depends on the power of the radiating source and the effectiveness of the antenna where the signal is propagated. So you can see that when it's propagated, there's actually two things that you need to look after, because it's an electromagnetic field that's being radiated. So there's actually an electric field and a magnetic field, and you can actually look at it with you can analyze them with differently with a magnetic field and a electric field. So as you can see, the electric field actually is coupled with wires and loops, the electric field and magnetic field, and the electric field, the current is generated in the cable. That's actually the victim, which is called actually field to cable. The current that's generated in the cable actually is done due to the electric field. That's why it's the electric part, and it's called the field to cable. And then we have the magnetic part, where its phenomenon is called actually field to loop coupling. The field to loop coupling is actually when the magnetic field, the magnetic force flows through the loop of the victim, and the victim creates a counter electromotive force that produces the actual voltage. That's the induced voltage, and between the two ends of the loop or in the victim circuit. So the thing is, I'm actually trying to find very much how to actually overcome this, because there's actually not that much, because actually this happens in a lot of ways, because there's intentional transmissions and unintentional transmitters. Thing is, like, we have unintentional transmitters like your normal ICs and your cables, connections, and even PCB traces. The thing is that these unintentional transmitters actually interfere with the intentional ones. Actually, your intentional ones are like your radars and your radio transmission equipment, like your TV transmitters, radios, walkie-talkies, and so on. So the thing is, like, what I've been trying to find is how to overcome this, but it's actually quite difficult, because there's actually two types. It's not capacitive or inductive. The thing is, like, what we can do is actually we can reduce the current and the voltage excited by the antennas, or eliminate the transmitting antennas, which is the unintentional ones, and block the radiating fields. You can actually do these three by actually understanding the high frequency sources, or cleaning the PCB layout in PCB layouts, and using shielding, which is mostly Faraday's. So actually, to stop field to cable coupling, which is done by electric fields, you can actually reduce the effect of antenna effect by reducing the height of the cable with respect to ground. That means you just lower it, the antenna effect. And actually we can actually also place the cable in bond metal cableway, which is kind of like doing some shielding, which is my next point actually, to use shielded cables. And for the magnetic part, the field to loop coupling, actually you can use as quite similar to the field to cable, use the shielded cables and adjust the height and length of the cable. But a more practical solution is to actually use a Faraday cage principle. Actually, with the Faraday cage principle, the shielded cable will both be connected to the metal case of the device. So actually that's how you overcome it. That's what I found, but it was very hard to actually find this.
That's interesting.
Okay.
We don't need to talk also lah, because we don't need to talk. We don't need to
One.
talk. I mean,
We
I
don't.
can
Hey,
remove.
Ramesh is over
I
there.
can remove. Okay.
1, 2, 3.
Hey, Faiz, Ramesh over there. Let's go find out.
Hey, Amish. Oh yeah, it's
Yeah,
them.
let's go. Hey, Ramesh, have you done your assignment?
Yeah, just finished.
Let's go. I'm damn hungry.
Yeah, we're hungry.
Let's go.
We haven't eaten anything since yesterday, man.
Wow. Okay. Let's go.
It's hot here anyway.
Oh, open your car keys.
Cut.
No.
1, 2, 3.